Hello, in this video I will do example 4 of a related rate word problem. So in example 4 states, an airplane at an altitude of 6 miles is flying on a flight path that will take it directly over a radar tracking station. If the line of the sight C is decreasing at a rate of 400 miles per hour when C is 10 miles, what is the speed of the plane? So the last sentence or the last statement says, what is the speed of the plane? That, what do you think that is? Is that a length or speed, or is it is a speed, right? And what do we know about speed? It's usually first derivative. So a speed is first derivative, so we got to find the speed of the plane. So I think we're gonna have to find dp dt. Okay, so this is kind of hard to visually see. An airplane at an altitude of 6 miles is flying on a flight path that will take it directly over a radar tracking station. So I don't really fly that much, but if you flew, this is what it should look like. So let's pretend you're in an airport or like some kind of runway. Here's the radar. This is where they keep who's coming in and who's coming out. I'm sure you've seen plenty of movies with radars. And okay, and then here's the airplane, and it is descending. It's going down on the runway. Okay, so here's the airplane, and it's slowly decreasing or going downhill until it lands, right? So the the line of sight is C, right? The line of sight. If the line of the sight is decreasing, which is true, it's going downhill. So this is the line of sight. C. And this distance here is eventually going to get smaller until it becomes nothing, right? Because it eventually the airplane will stop. Okay, so let's somehow, this is probably the best image I could think of. Airplane going downhill until it lands. Here's the radar. And let's just kind of write down what we have. It says an altitude of 6 miles is flying on a path. And then they also say if the line of the sight of C is decreasing at a rate of 400 miles. So this forms, what does this form? It forms like a kind of like a rectangle, right? So this image right here forms like a rectangle, or in our case, it would be two right triangles. So this is the transversal or the line of sight. And yeah, the transversal is 6 miles. Or this distance here is 6 miles. And this, we'll call this, so this forms two right triangles. And this is the C, the the line of sight, and we will call this, let's call this distance P right now. You could call it anything else. You could call it X, Y, Z. So, and then they also tell us that the line of sight is decreasing at a rate of 400 miles per hour. So that is a speed. So that would be DC dt at minus 400 mph, so miles per hour. Okay, and when C is 10 miles. Okay, so what are we trying to find? So uh, yeah, so this forms two right triangles, and these two lines are parallel, and I believe that these two angles are congruent. And we got to find dp dt. So now what we need, so we draw our best image we could think of. Now we have to come up with an equation. So the only thing I see right now is two right triangles. So let's break it into one triangle. Here is 6 miles. We have 1p, and then this is c. So this is related to a right triangle. So we, what is the area of a right triangle? Or we know that this is, we could use Pythagorean theorem, right? So Pythagorean theorem is a squared plus b squared equals c squared. So if we use our Pythagorean theorem, it would be one of my leg is p, so it would be p squared. One of my other leg is 6, so 6 squared is 36. And then my hypotenuse is c, so that would be c squared. So how many variables do we have? We have two variables. So that means we should have one rate. And that's true, we do have one rate, which is negative 400 miles per hour. Okay, now we just take we implicit differentiation in respect to time. So start with p squared. What is the derivative of p squared in respect to time? Well, I know that the derivative of p squared is just regular 2p. And in respect to time, you do have to add this dp dt. What about the derivative of 36 in respect to time? Well, the derivative of constant is 0. And then what about c squared? What is the derivative of c squared in respect to time? So the derivative of c squared is just 2c. And then you do have to add dc dt. So what are we trying to find? We said before we were trying to find the speed, dp dt. So dp dt, that's what we're trying to find. And I guess we can plug in our dc dt as negative 400 miles per hour. So let's kind of clean this up. Well, yeah, let's rewrite. So I'm going to rewrite this as 2p dp dt equals, and then this is 2c dc dt. Okay, so we are trying to solve for dp dt. So let's get rid of this. I think I just have to get rid of this 2p. Wait, can we, I think we have, oh, we have a value c. C is 10 miles. So let me put that in. And then DC. Let's also put, no, you know what? I'll just get rid of the 2 first. Let's just get rid of this 2 by dividing both sides by 2. So now I have P, dP, dt. And over here, the 2's cancel, so you're left with C, dC, dt. Okay, and then what else? We gotta solve for dP, dt. So I have to get rid of this P. So I'm gonna divide both sides by P. This cancels, and then you're left with dP, dt. And then we can plug in C as 10 miles. Careful with the units, make sure you bring down your units. So this is 10 miles, and then we can replace dC dt with negative 400 miles per hour. Divided by p-value, which is my p-value, actually my what is our p-value? Do we even have a p-value? We do, actually. We could solve for, if we go back to our right triangle right here, we said that this C value was 10, so we could find our p-value. That's what I should have done. So let's go back to this right triangle and let's replace C with 10, and then let's solve for P. So how do we solve for P? We can now use Pythagorean theorem, so it would be P squared plus 6 squared equals C squared or 10 squared. So this is P squared plus 6 squared is 36, and 10 squared is 100. Solve for P, so I'm going to subtract 36. So this is P squared equals to 100 minus 36 is 64. And then take the square root of both sides. P is plus or minus 8. It's just wise to not use a negative length as our P. So I think we'll just use positive 8. Okay. So this would be that, and then you replace P with positive 8. Okay, so this would be 10 times negative 400 is negative 4,000. So this would be, I'm trying to think, what is my unit for P? Wouldn't this be miles? So this is miles. I'm just trying to see if what would be my unit. So this would be, so 10 times negative 400 is negative 400, and then miles squares, because miles times miles is miles squares per hour. And then divide this by 8 miles. Okay, so I know that negative 400 divided by 8 is definitely negative 500, but what would be my unit? So this is a little bit tricky. We have a complex fraction. So we have, this is your numerator, and this is our denominator. So you can rewrite it as miles squared per hour divided by miles over 1. If I cross multiply, this would be 1 times miles squares is miles squares. Hour times miles is miles per hours. And then as you can see, the miles cancels. This becomes 1, so that makes sense. So it is definitely miles per hour. Okay, so, and I guess you could express this in a sentence. I guess you could say the speed of the plane as it lands is decreasing of 5 miles 500 miles per hour. So you could say incomplete sentence, speed of the plane is decreasing of 500 miles per hour. Okay, so this one was tricky because I had to draw the correct image. So this is example 4. Okay, that wraps it up for this video.